This time it really is good afternoon, good morning, and good evening, because I am joined at lunchtime o'clock in South Africa by AJ, who's in Japan in the evening, and one who's in the morning in Florida. Chats from ComQuest Ventures. Good morning and good evening to you. How are you doing?
Good evening.
Hello,
how are
everybody,
you?
and
that all went well, didn't it? So you let me try your software. Your software is Typhon. It's Typhon UDX, and it's for designing drones, if you will. And very impressed I am as well. But how did you reach the spot? Why would you guys, with one person in Japan, one person in Florida, why would you end up designing drone design software? What's it all about? Juan, do you want to take that?
Yeah, sure. Thank you, Gary, for having us here today. And so, as you said, we are the co-founders of ComQuest Ventures, and we're a company that we focus on creating drone design and simulation software for drone developers and academic institutions. And initially, our company, we started working on the hardware side and focusing on VTOL technologies, hybrid UAV designs. And these designs happen to be quite challenging from the engineering side to design, because the requirements for vertical flight are quite the opposite from the requirements for forward flight, and that makes it very challenging to design. And in the process of making our first VTOL design, we realized that the engineering tools that are out there are quite limited, and they really haven't kept up with the advances in the UAS technologies. So really, we started creating this tool, which we call Typhon UDX, at first internally for us as our own development tool. And we developed it throughout the years through a number of projects, of VTOL projects, which we created. And just about a year ago, we took it to the point where it was validated enough and tested enough that we thought it would be useful for other companies. And we are now releasing the software to the market, and we're really shifting our company into focusing on developing this UAV design tool.
I think it's a very, very smart move. The hardware world is a shark-infested waters, if you will, and I think it's a very smart move to do this, because many people need this sort of thing. So AJ, you're in Japan, and I think you're both brothers, you guys, but you're the software man, I think, AJ.
That's right. I work on the graphical design, graphical user interface design, and I also work on developing certain features as graphing features and adding any sort of features around the core aerodynamics engine of Typhon UDX.
And you've got the model of your machine. I can see it over your shoulder there. Is that the Vertex? Is that the thing that's in the demonstration software that I've got?
Yes, actually, what we have here is this is just a small scale model of the Vertex. It's just for basically for inspiration. Juan created this small scale model. So maybe Juan can briefly talk about the design.
Well, it's going to that's going to be of interest to me later, because I'll have some questions. But I think why don't you lead me through that? So I've used your software. Regular viewers of the podcast, whatever this is, know that when I do something, I never read the manuals. I've managed to get, and the reason I don't read the manuals is because users don't read the manuals, and not because I'm lazy, or is it? I've managed to get, I by chance happened to be having a play with another tail sitter, and I managed to get it working in there, and it wasn't too hard. And but perhaps you could walk us through how the software works and show our viewers exactly what the workflow is.
Sure, let's do that. Can you see my screen?
I can see your screen.
Okay, perfect. Well, we have spent a lot of time on thinking about the user interface and how to make it flexible yet easy to use. And you can tell us if it was easy to use for you. We sent you the software about a week ago, and you said you didn't read the manuals. but still you were able to create a model of your own VTOL design, and I saw it flying yesterday, so so we're glad about that. But how you can see the interface here, and the way it works it uses a number of independent windows like this one. We call them panes. So the way the interface works is you have a number of these panes, and within each one you can select what you want to see, which visualization or interface you want to see on that particular pane. So let's see how you use this interface to create a UAV design. So the idea is you have a number of parametric components you can combine. For example, you have wings, airfoils, wheels, electric motors, and just a large number of components. And then you add them to your design as such. And then you can go here to the editor pane, and then you can edit the component. And each one is parametric. So that means in the editor pane, you can see all the parameters that define the design for that component. For example, for the wing, you can change the chord and the span, and you can add multiple wing sections. And that way you can create quite complex wing designs. You can also select your airfoil from a large database of different airfoils.
I must admit, I'll stop you there. That's one thing I found hard. That's that little double set of arrows up in the top right. I didn't see those immediately, but I got there in the end. So you need to make that a bigger button, or I should read the manual, one or the other.
Right. Or if you make the pane wider, then it shows up right here. So
okay.
yes, these buttons up here are the database manager, because each component has a database. And for example, for the airfoils here, you can see all the available airfoils, and you can just select one from there. But also let's add for example, a brushless motor here, and I'm gonna move it around. And when you go to edit that motor, you see the parameters that define that motor, and you also have a database. In this case, we include the T-Motor brand motors. So you can
I hadn't seen that. I was entering that in manually. I'll move the panes across.
Yeah, it's useful because you can either enter manually the parameters from the manufacturer, the KV and no load current and all of that, or you can just select one from the database. And so the idea is you can combine all of these components and create pretty much any UAV design. One of the components is a hinge, and this allows you to tilt, for example, tilt motors for thrust vectoring, create a tilt wing or anything like that. So
that was exactly one of the questions we've already had, is if you could use articulated motors. So that's cool.
Yes, you have hinges to rotate, and you also have linear actuators, so you can even move components linearly back and forth using a servo. And the idea is that you can create very flexible UAV designs, and here are some of them. For VTOLs, this is one of our VTOL designs, which is fixed wing SLT. So it has separate motors for vertical takeoff and for flight. This is what we call the Vertex, which is the one I mentioned before.
And that's the one that you had the model of in the background. Is that is that swivel motors on that then?
Yes. So each motor is on a hinge, so it can tilt independently. It's a tilt rotor design.
And that one's gone a little bit more then. It's gone from design to real life. That's not just a thing in software.
Yes, and this is one of we created the software at the same time as we created this design. So we created software based on our needs on making this actual VTOL. I'm
gonna interrupt your walkthrough a little bit, but for me, just for interest's sake, why did you choose a canard design for that? There's not many separate lift thrust canards out there.
Yes, well, the main idea of this design was to put the motors on a pusher configuration, so that when you are hovering or on forward flight, the prop wash of the motors just doesn't hit the aircraft. And obviously, you want at least 3 or 4 motors to have hover stability. It's more stable to have 4 than to have 2. So in this case, the tandem, it can be a tandem design or a canard design. The idea is that you can place the motors, one motor on each wing, and it just it combines very well because it allows it to have a stable design on forward flight and hover that also combines well with the placement of the motors in a pusher configuration.
Canards are always the canards, if it's a standard aircraft, are always a nightmare to slow down because the thing doesn't want to stall, or it pitches the nose down. So, but you're going to get around that because you'll be landing in a hovering mode. Sorry, I'm going a bit off topic, but it does strike me as a very interesting way of doing it because, of course, you're taking less wing area around on the journey. People anyway. So, well, I've gone off topic.
No, yes. In this case, you can even tilt the motors forward to slow down, and the canard configuration has some benefits for VTOLs because, so for example, if you are climbing vertically on hover flight or you're descending, it doesn't want to pitch down or up as strongly as a standard design. So it's more stable at very high angles of attack, which is useful for VTOL for a VTOL aircraft, and it has some other benefits, but we can discuss them at another time, I guess.
Yes, sorry. Maybe keep walking us through.
No
problem. Shut up. I'll be quiet
now. This is another. Well, you can create also fixed wing aircraft, including flying wings. This is a tilt body design, another type of VTOL. But you can also make just standard multicopters, and you can also create standard fixed wing aircraft, such as just a standard trainer. You also have nitro engines or gasoline engines, so it's very flexible in the types of design you can create.
You're not old yes. enough to remember nitro engines. You don't know what a nitro engine is. You're too young.
No, actually, the first one I flew was a nitro, so this design brings good memories.
Yes, that's for a lot of people.
Yeah. So let me just load this trainer so we can move on and see. So once you create your design, the idea is that you can instantly simulate it. So let me change this pane here to a simulation mode. And I have a USB controller connected to my computer. And then I can manually fly my design. And the dynamics and the aerodynamics, the physics, everything updates on real time as you edit your design. So I can go in now and edit any aspect of my design and see the effect on how it flies, on the performance, on the dynamics and everything. And
why don't you drag the CFG back to some ridiculous place and show it out the way? Just show us, make it unflyable. And then we have a question that the propellers for the tandem plane are directly below the wings. So do the wings block any airflow? Is a question from the crowd of 3.
Yes, that's true. What we do is we shift the propellers back to limit that effect. And also that effect is important only in hover, and what's important in the VTOL is mostly to get good efficiency in forward flight. So that is an important effect in this design, but it has other benefits that outweigh that effect.
I must admit, I found with playing with my design, I did find moving the CFG up and down, changing the length of the nose, and I found that very interesting to see the effect on it. Another question I had for later on, but I'll ask it now. How would I get this into the real world from where I'm at now? What's the workflow into that? Maybe I've jumped too far ahead.
We can discuss it a bit more later, but basically this is the idea of the software is general. We call it UDX, UAV Design Explorer. And the idea is to use this on the early design phases, on the general design. So here you're not doing detailed structural design. Here what you're doing is selecting the airfoil, selecting the wing shape, selecting the propulsion system. And after you do all that, then you can move to CAD software, for example, and do the detailed structural design and then move into manufacturing. So really
can I bring that more detailed CAD design back in and run that through through the system, or
you can export the 3D model and, for example, use it in if you want to do a CFD, a computational fluid dynamics analysis, you can use that model for that. But in general, when you want to do the detailed structural design, what you use is the overall design you get from here. So you already know the wingspan, you know the chord, and you know the general design, and from that you can create the detailed design.
Yeah. Okay.
So let's do what you suggested. Let's change the center of gravity of the aircraft back, and at some point it should become unstable. So here I have the editor pane on the right, and here's the center of gravity location. So I can just click here and then move it back with the mouse, and let's start moving it back. Okay, I'm not touching the controller now, and you see it started looping.
Yeah.
Because it's become unstable, and if I move it further back,
so I guess what we
losing
did,
control. Yes.
What I didn't articulate or didn't say was that, so you've got your batteries, your speed controller. Well, one of the things I really liked about it was, and what I eventually worked out in my dumb head was that you have to build it as if you're building a model airplane. And if you don't have a battery connected to a speed controller, connected to a motor with a propeller attached to it, nothing will spin or work. So I found that pretty cool in the end, because when you're designing in this, the propeller will start spinning. And when the propeller starts spinning, it's because you've connected all the bits up in the right order, and you connect it to the flight controller. So not only are you doing the electrics, if you will, but you can then position everything to help get your CFU, put your target CFG in there, and then position everything, all your weights and masses correctly. And I thought that was pretty cool, and would help you quite a bit in the layout of the grown-up CAD model that you do afterwards.
Yes.
No, sorry, I was again going off topic, but I thought that was very cool.
No, yeah, it's good to mention that the software estimates the mass of each component and of the entire aircraft, including the CG. So, for example, here I set the CG manually, but if I click here on auto update, it will calculate it automatically based on the mass of each component. So that way it can help you place components to get the CG where you want it, where to place the fuel tank, for example.
Does it simulate
yes.
in the nitro thing? Does it simulate fuel flow, fuel weight going down of the aircraft?
Yes, you can see the mass here of the aircraft is going down, and the CG is also changing slowly as it consumes the fuel. So yes, as you consume the fuel, the CG is going to change the mass, and that's something that's accounted for.
Okay, so I mean the opportunities I see for exporting something to a more grown-up simulator like X-Plane or something, and running really long tests on it once you've done that, I see loads of possibilities, because of course playing around in software is always much cheaper than actually cutting wood and cutting foam and buying motors and all that sort of thing. You can get yourself to quite an advanced point before I'm singing too many, but I've got to be critical in a minute. I'll be critical. I'll find something in a minute. But it's a great idea. And so you can design anything you can think of, you can have a go at making. And if it won't fly, if in the real world it wouldn't fly, it won't fly in this, will it?
Yes, basically that's the idea behind the software. And as an engineer, this is an engineering software, and as an engineer, we explain to our customers, we give them an idea of the algorithms that are being used behind the scenes. So the engineer understands that way the limitations and the strengths of each algorithm that is being used. And as in any engineering software, you have to account for that in the design process, so you know what to trust more from the predictions of the design. But overall, yes.
Sorry. In the questions we've got, so it's a primary for sketching out design ideas, and I think I could say that, but quite a high fidelity, not so much of a guess, a quite high fidelity sketch once you get there.
Yes, we try to get the idea of the software is to run on real time, run very quickly, and in engineering there's always a trade-off between how long it takes to run and how accurate it is. And for example, computational fluid dynamics is very, very accurate, but it takes days to run and to set up. So our idea with this software is to get the best algorithms that can run on real time. So the most accurate ones we can get, but they can still run on real time. And for example, in
Yeah,
the
I
area
like
of
to mention.
aerodynamics, yes.
Yeah, sorry to interrupt. I'd like to mention that the idea also of Typhon UDX is not to replace our tools, standard tools used in uh, aerospace engineering, such as CFD, such as CAD tools. They are complementary. So what we bring with Typhon UDX is the ability for the engineer to explore infinite designs quickly, and then move to more higher fidelity, but much more lower, much more slower, and more terse tools. Yep.
Yeah.
That's right. If you see the trends in engineering, the latest trends are to focus more on the early design stages and to get tools like this that are multidisciplinary, combine multiple disciplines, and run fast, even though they are not as accurate as they can be. But when you have that kind of tool, you can focus, you can improve the early design stages. And then you explore many more ideas early in the design. And when you go to the detailed design, to the prototyping, you spend less time there. And overall, the whole process is accelerated. And that's really
Maybe
the spirit of this software.
maybe for me, I'm sorry I'm being rude. Maybe could you run us through the difference between the test? Well, what's the difference between the test flight pane and the simulation pane that you're in now? And then maybe also I'd like to be run through the wind tunnel as well, if you may. So help me understand it some more.
Yes, can you repeat the beginning? Your voice cut a little bit. Yes.
Sorry, the first one is the flight test pane that comes up.
Yes.
What's that one about? And then have a look at the wind tunnel. So I'd be interested to hear out more about those.
Okay, so again, you have many different panes to help you design your aircraft in different ways. And in the simulations, yes.
And maybe put one of your tail sitters or separate lift thrusts in there. So because I bet some viewers when they arrive will think, oh, it's only for designing standard old nitro model planes. Right. So switch out to one of those. Yeah, that's it.
Or let's use a vertex here. It's more interesting.
There we go.
So you have the simulation pane, but you also have the flight test pane. And the idea of the flight test pane is that it's also a simulation, but there's just no ground. So there's no way of crashing your aircraft. And if for example, if you're changing the design and testing different things, it's better to have it fly in an infinite space where you cannot crash it. That's basically the idea. That's a utility of the flight test. And I'm showing here the vertex. I'm gonna transition it to hover flight. And so now it's hovering.
Have you done that based on the position of the stick, or have you done that on a switch?
Oh, so you can set up your different USB transmitters, and you can very easily configure them. So you can have you can assign channels to switches or to buttons. In this case, I'm using a button, and when I click that button, it's gonna transition. But you can also use a knob if you have one on your transmitter.
And the so what we're going to see in this transition then is, does the nose pitch up and the motors move to slow down, or is it?
So on this case, just the motors tilt, and then you can manually pitch it up to slow it down. And when you transition forward, the motor is still back and it starts moving forward. And it has auto level feature, so it maintains the aircraft level on pitch and roll as it transitions.
Now look, yours is as you rolled left and your nose went right. Then that's like your nose should be following that around a bit more.
Well, I'm just flying it lazily right now, just as a demonstration. And also, I'm gonna talk about this later, but there's also the software side, the controls side of the software. And for example, obviously, an aircraft like this or a multicopter needs some flight control code to stabilize and control the aircraft. And the way Typhon handles this is that you can add a flight controller component to your aircraft.
Yes.
And when you add that, you get a script, a code script created on your computer, where there you can write the code, the flight control code that controls your aircraft. Or the second option is you can connect it to the actual flight control code, be it PS4 or Pilot. You can interface it to the actual code and have the actual code fly your aircraft.
I pulled
So
yes. Because you need hardware in the loop. How do you connect software in the loop?
So hardware and software in the loop is basically the same. One of the scripts you have connects. It's made specially for example, for the PS4 or for the Pilot. So you put the flight controller component to the aircraft. You select in the editor pane that from the database, you select for example, the PS4 flight controller, and then it will automatically be set up for interfacing with the PS4. That's basically how you do it.
Yeah, I tried doing that with hardware in the loop. I was sort of going along, but I failed. I'd love to. Again, in the comments, CG features are pretty cool, especially the fuel flow simulations. That's where I face the most difficulties when building new frames or adding lots of electronics to convert a frame to VTOL. No, you can. You really can. Honestly, I don't work for them. I don't work for them, honest. But you can move everything around and have it as you want it to be. I was pretty impressed. So that's that. That's just so that pain really is so you don't crash while you're testing it. What
Yes.
can you modify while it's flying like that then?
Well, anything really. Let's see. I don't know, the wing.
Okay.
Let's move it. Let's move the leading wing. Let's move it forward. Or I don't know. Let's increase the span of the forward wing. So I made it bigger and it started pitching up because it has more lift on the front. So let me make it even bigger and it's pitching up even more. Or let me make it very small and see what happens.
Yeah.
So I made it quite small and now it's pitching down, but it's still kind of flying. So you can change anything: the airfoils, the locations, the propellers, the type of motor, basically anything.
Okay, so that's crackerjack. We've probably spent enough time on that. The wind tunnel. Show me the wind tunnel.
Okay. Let's go into the wind tunnel pane here. So this one basically showcases the aerodynamic model we're using, and the aerodynamic model is such that it actually predicts the flow of air around the aircraft based on your wing design. So this blue line here is a streamline. It is the path that the air would follow around your aircraft. And as I move around, you can see how it interacts with the wing, or here with the flow of the propellers is being pushed down. And even as you move the control surfaces, you can see it's deflecting the wind upwards. So basically, this type of aerodynamic model we use is quite unique. It's basically the best you can get if you want it to run on real time. And basically, we haven't seen it being used that way in other software. You usually run it offline, and then you see the results. In our case, we're running it on real time. So that way you can get a very high quality aerodynamic prediction on real time as you edit your design. And that's really what this pane allows you to do. But the utility of this pane is really that, for example, on a design like this, you can have interactions between the two wings. And here you can see how the downwash of this wing pushes the air down a little bit. And that will affect how the rear wing behaves. So this way you can see interactions between wings, interactions between the wing and the tail of the aircraft. Let me show an example here. Load the trainer again. Because this trainer has flaps, has ailerons, but also flaps. And as an example, let me increase the airspeed. And I'm going to plot here. These are the force vectors on the aircraft. these little lines. This is how how the air is pushing on the aircraft. And on the tail, it looks like this because the propeller is creating a slipstream that goes around. It has some vorticity to it, so it pushes the tail on this direction. But what I wanted to show you is that when I put the flaps down, I'm gonna put them down now. You can see first that the lift increases on the wing, but you can also see if you watch closely that the tail actually pushes down more. So flaps down, flaps up, you can see that this force vector change. So that's basically because when you put the flaps down, it's pushing the air down more, and that is affecting the tail, and that is what makes the aircraft climb up, want to pitch up when you put the flaps down. So you can see that type of things using the wind tunnel pane.
Mm. Mm. No, a lot of the features of this are beyond my pay grade. Really, I was just pleased to be able to have something that I've made in real life and start simulating and fiddle around with it. Well, I'll let you continue. I'm not sure what order you want to do in things. I don't want to drive this too much.
Okay. Another important aspect of the software is the performance prediction aspect. So let me open here the performance layout. You can also save layouts of your panes, so you configure your panes how you want, and then you save it as a layout, and you can open that layout later. So I just open a layout with the performance pane here. And the performance pane is able to give you predictions of the performance of your aircraft as you edit it. So you don't actually need to fly it to see the maximum speed or to see how long it flies. You can actually get those predictions right here on this pane. So for example,
those are going to help you set up your autopilot when you do it, because that's giving you some starting figures to play with in your autopilot.
Yes, that's right. So for example, you can go into endurance predictions and you get the maximum flight time of this aircraft, the maximum range, the speed at which you get maximum range. You can get all sorts of predictions, the payload the aircraft can carry. You can see the aerodynamic coefficient curves that the software is predicting. But you can also see performance predictions of specific components. You can go to your propeller and see the thrust coefficients, the power coefficient of your propeller. You can see the curves, the torque and power curves of your engine. You can see the dynamics of your airfoils, the airfoil pullers, and you can get all sorts of predictions here. So the idea is that this can help you quickly optimize your design. When you're designing UAVs, usually you have conflicting design goals. You want to fly the maximum time possible, but you don't want the aircraft to be too big. You don't want the wing to be too big. So these conflicting design requirements make it difficult to design. But if you have a tool like this that you make a change and you instantly see the effect on multiple aspects of the performance, then it really accelerates that process of optimizing your overall design.
So you've got that pane that shows the simulation and then the flight controller inputs and things like that. What's the purpose of that? You've got simulation on one side, and then you have all your graphs running along.
You mean this one on the right?
No, you've got one. I can't remember what it's called. Where you have a little simulation image, and then you can put all the another question now on the wind tunnel in the comments. I see you on top of that. You can see what the servos are doing. You can see what the motor's doing in a graph form running along as the aircraft is flying.
Yes, yes. Thank you for mentioning that. That's an important one. Let me go back to the simulation with this trainer. And one of the panes is called the state pane. I'm going to open it here on the right. And here you can see the state of the entire aircraft or of individual components as it flies. So for example, here I can see the location of the aircraft, the velocity, the angle of attack, the lift force, but you can also go to specific components. Let's say, let's look at the propeller, and you can see the RPM of the propeller. You can see the thrust on real time as you fly it. You can go to the gas engine and see the consumption. So basically, you can observe all the state of the aircraft and really look at what's going on. You can even see, as you mentioned, how the servos are moving around. And you can
Well,
also
maybe you can
manually,
also
yes.
activate the flight plotter.
Yes, another way to visualize the state is the plotting pane. So you can see it on a graph on a table like this, but you can also create a plot of that data. So this is a plotting pane. You go here, you have all the state parameters of the aircraft, and then you can select what you would like to plot. Let's plot the speed, and as I fly it, you see it's creating a plot of the speed of the aircraft. So you can plot a pitch, roll, basically anything, any state parameter of the aircraft. You can plot it and see it on real time.
Do you have the ability to show us it flying a mission connected to I've forgotten the name of that mission planning software? Have you got that set up on your current machine?
I don't have it set up right here, right now.
Okay. I should have said that. Sorry, but you can, can't you? You can run a simulated mission with your aircraft.
Yes, you can do exactly what I'm doing right now, but have the flight controller fly the aircraft, and you can see all these plots. You can see everything that I've showed. You can see it as the flight controller is flying the aircraft.
And you can then connect to the ground control software, station software, to use them in combination, the flight controller, the GCS, and Typhon.
Yeah, so once you've designed your aircraft and you've got a mission for, funny enough, actually, I haven't thought much about needing a heavy lift multi-rotor, but yesterday I did, because I've got to move some logs up a big slope, and I was thinking, God, I wish I had a multi-rotor that would lift 50 kilos of logs. So if that were my mission, I could set that up and see how that would work, or a delivery or something like that, and see if my aircraft really would meet my design requirements before, again, I start actually paying money out and buying stuff.
Yes, that's the idea. You can also you can plan missions, you can rehearse them, you can see. Also, you can change the environmental conditions. You can add turbulence, wind, and test your mission on different conditions. And there's also this other feature I wanted to mention quickly, which is the recording pane. This one allows you to record a simulation and play it back. But the other neat feature is that you can also load flight logs from actual flights. So we made a flight with one of our VTOLs, and I just clicked load here and loaded that flight log from that flight, and I click play, and this is actually playing back that flight which we did, and it's flying like this because the actual aircraft is a VTOL, so it's taking off vertically, and you can see all the plots, all the state. You can actually use this to explore the mission and analyze your flights and see what's going on. So yeah, this is playing back based on the recording of the actual mission.
And then if I was playing back a flight that happened on a calm day, it was nice and easy, and I knew it was going to be, because that's when I flew it. Could I change the weather on that playback to make it windier, or?
Yes, but it's basically like it's an animation. It's animating back the data,
Okay.
so the wind is not going to change what is already recorded.
Okay.
Yes.
Okay.
Yes.
So you started out because you wanted to design your platform, and you've ended up with this software because it was something you needed. I'll have to ask the question: what's happening with your platform? Where's that at? Has that been parked now in favor of this, or are you still continuing development of that?
You mean our VTOLs?
Yeah, the Vertex.
We refocus it as a research platform for us, and as a platform to help us develop this system. However, we are still pursuing a patent for it, and we are still open to developing it into a commercial product in the future. But at the moment, we are really focusing on this software and how those designs can help us improve this and test and validate this software.
And maybe you could just show me the flight control on what to how to set that up, because I was a little bit lost with that. I was rather hoping I could, maybe I could if I'd read the manual, connected up to the ArduPilot software, which I'm more familiar with, and run that. My head would have been in a little bit more. Where is that code bit hiding then for the flight controller?
Yes. So again, when you add a flight controller to your aircraft, it will create this script. So basically, you go to the installation directory of your software, and you can go here to component database, and here you can see all the database of the software. And actually, you can yourself add components to this database because they're all, for example, the airfoils. It's just an XML file which is readable by a human, and you can write it manually. So you can expand these databases. And one of the databases is the flight controller. So when you go here, you can see, for example, let's go to the Vertex controller. And it's a Python script. And we use Python because Python is quite easy to work with, and it doesn't need to compile. So you can really quickly test ideas here. You can also import any Python library if you want to use it within the software. So basically, this is the script. You can define some parameters which you can edit from the interface, from the GUI itself. For example, the PIDs. I'm setting here which variables I can edit and the range. So this will be available in the GUI. So you can change it from here. You don't need to change it on the code. And once you define that interface, you actually write the control code, which is right here. And these are the PIDs that stabilize the aircraft and manage the transition and everything. So basically, this update function, you will get all the sensor data from your flight controller. You get latitude, longitude, roll, all the state of the aircraft. You can do whatever you want with it in here. And then you return the control signals. And then on the GUI, you can connect servos to each control signal or speed controllers so that this way your code controls the aircraft. So again, you have this option of doing it manually here in Python, and this is very useful for prototyping. You want to create a prototype of a code. For example, for the Vertex, there are many ways of controlling it. It has so many degrees of freedom that you can do it many, many different ways. So here we test the different ideas quickly. How about we do it this way or this different algorithm? And when we converge on an algorithm, then we, instead of using this Python code, we use the actual code, the actual PS4 code interface to Typhon, and we implemented the prototype. We implemented in the actual final code and tested it using Typhon. So this helps you not only prototype but actually do the final implementation and test it.
And so for numpties like me, that is well above my pay grade. Will the ability just to create a parameter file in ArduPilot come along, and I can, or import and export, create a parameter file from that I can chuck into into ArduPilot, and then similarly drag one in? I mean, would that be possible?
Well, when you interface Typhon to ArduPilot or to PS4 or other flight controller, you can actually tune your design as you would in a real life, but in the simulation instead of doing it in real life. So you can find the tuning, and you do it through, as you do in real life, you do it through GCS or on GCS you tune it, and then you can save that file and you can use it in real life. And in our experience, for example, for the VTOL I showed, we use actually the same parameters in the simulation as on real life. So we were able to do the tuning on the simulation
Well,
and go to real
that's
life and require very minimal tweaking, but actually the same tuning worked on real life.
well, that's what I was hoping to get to do with mine, so that I could put it into RGPilot and run from Mission Planner, run an auto tune. That's what I was hoping to do, but again, I failed to get there. But I didn't look at the manual. So maybe in the next version, if I've got to be critical, maybe if you could hold people like me's hand a little bit more in that way of connecting to RGPilot, I'll be very very pleased with that. That would have been a great help.
Yes. Yeah. So for our clients, we always offer like a training session where we go into detail into everything, because it's meant to be. We created it for users to use it like you did, without many manuals. Just go in and test and try different things and learn that way. But still, with our clients, we do offer training, so we show in detail how to do everything, because there are
And
many different things you can do. Mhm.
absolutely. No, I'm very impressed at how feature rich it is, and it does absolutely, for a rapid prototyping, it absolutely makes sense. I completely get what you've done, and fair play to you. I think it's the only thing in the market like it at the moment. But the only thing I'm a little bit worried is you're pitching it to VTOL aircraft. It's actually anything. Any aircraft you could, any electrical nitro aircraft you could design in it, and it seems a shame. But VTOL is the current darling of the moment. I guess that sort of leads very nicely to how much does it cost? What's this cost?
Well, we don't say the price publicly. We say it to our clients, but basically it's designed for UAV developers, even small ones, even startups or large companies, and also we license it to academic institutions directly, or to research institutions. That's mainly our market right now.
Okay, and actually, maybe you could help me through how would I export my model now to use in another program? What formats can I export what I've worked with or modeled so far?
Okay, so if you go back to the editing pane, um, for example, you can go to the wing, to each component, and you have this visual models interface, because you can also import, if you have for example, a very detailed 3D model of your design, you can import it, and it will be used for the visual aspect of it. The physics are still computed based on the parameters you enter here, but you can specify a 3D model so it looks visually better. But you can also use it to export the model that Typhon created. So click here, export, and it will create just a mesh file, which you can import on CFD or on some other software.
Okay, and it hasn't sent any of like the weight values or CG or anything like that. It's just a mesh of the outside
Right.
look of the thing. Yeah. Okay.
Yes, that's correct. But also we are continually expanding the software and adding new features, because we made the software to be flexible, not only the user interface, but the physics engine that lies behind it is made to be very flexible. So we can add new, for example, we can add new types of components, we can add new features, we can export data, we can interface to other software. There are many things. We can add new types of visualizations. So the software is flexible, and we are continually adding new features based on what our clients need.
Have you thought
Yes.
about helicopters yet? Or can you
We
do
recently had
helicopters?
Yes, we recently had a potential customer ask about rotors and helicopter rotors, and we are considering adding. Basically, it would be like a new component, rotor, and that will basically allow you to create helicopters or other types of VTOLs that have for example, variable pitch or collective or all of that. That's one component we might add in the future.
Well, I don't know. Is there anything else you'd like to say? And any of our three viewers, any other questions out there? Because I think I've taken enough of your time now. Going once, going twice. No. Well, thank you very much. and I really have enjoyed using it and getting to understand it. It really wasn't all that hard for even me to catch up with it. It strikes me that it's be something that would be quite good for community-based design as well. You know, chucking, if you had a forum of designs, and it looks as you can add components to a database, user-created extra components and bits that would go well with fit well with the community.
Marketplace to exchange components, designs.
Yeah, and then, you know, I've had a go at this, or you could say, you know, I can't make this fly or whatever. Dave, can you make this fly? You know, I can instantly see other people helping people and collaborating a little bit over the designs. In fact, can you share the save the designs and share the designs and load it elsewhere?
Yes, you can. You can. It's just sharing the files, and yeah, you can share components from the database. You can share whole aircraft files. You can share the flight control scripts or anything. And also, we have a specific version of the software, which is we call it Typhon DMX Drone Mission Explorer, and it's just the simulation aspect of the software. So it's just a simulator. And some of our customers have, for example, one full Typhon UDX and a few Typhon DMX. And if they have, for example, their pilot can have just a DMX, and their engineer designs the aircraft and sends the file to the pilot, and the pilot can simulate it. And they can use that simulation for demonstrations, for training, for tuning, for anything.
And that simulation will again connect to some of the mission planners and things like that through Mavlink.
Yes.
That's very cool. So you can test it in your work group. That's very cool. That's a very good feature. I'm gushing too much about this. I'm not finding enough to criticize. I'm sure other people will find something to criticize. Gentlemen, thank you very much. Thanks for taking the time for joining us from both Florida and Japan. That's very impressive.
Thank you, Gary.
I
really appreciate it.
I'm impressed. Please keep us up to date with any changes or anything that happens with it, and I look forward to hearing all about it and reading about your success moving forward.
Thank you very much. Thank you for having us.
It's only a pleasure. Thanks very much, dear viewer. Don't forget to join us at 21 GMT every Tuesday for drone stuff this week. I'm not sure what I'll be doing this weekend. I'm going to fly something or other, probably more range testing of open glider network stuff, and we'll look forward to see you on Tuesday. Cheers, chaps. Cheers, everyone. Bye-bye.
Thank you.
Cheers.
Bye.
Thank you.